Hello, everyone. We're just going to wait a couple more minutes while people are coming in. Okay, let's get started. So it's my pleasure to moderate this plenary session titled New Data Sources, Perspectives, and Challenges. We have three distinguished panelists that I'm going to introduce a little bit later. It's been quite inspirational for the past 2 days and this morning as well. Looking and learning about a lot of applications of transit ITS data, the conventional ones, the application of AVL, APC, and AFC, but we've also seen a few presentations on new data sources that are being also used in isolation or in fusion with other sort of traditional data. So it's a very exciting time now that we have other opportunities for more data to really analyze and optimize our transit system, both at the planning level and also management and operations. So the intent of this plenary is really to learn more about some of those new data sources, but also to learn about the issues and challenges they bring with them. There are obviously a host of issues that we have really to address while using those new sources of data with respect to quality assurance, with respect to privacy, and so on and so forth. So I said we are quite fortunate. We have three distinguished panelists. But before actually I turn it over to the first speaker, we're going to have two polling questions. Willem, if you can share those, please. Okay, so this is a question addressed to all, both academics and practitioners. Have you used new data sources as inputs to transit planning and operations? So that's the first question. Check everything that applies. And the second question is, have you encountered privacy concerns in using new data sources? So let's give it 30 seconds or so for people, or maybe 1 minute for people to answer both questions.
Results are still coming in.
Okay, yeah, let's give it a few more seconds. So those are also questions or that the three speakers are going to address in their presentations. And throughout the discussions that will follow the presentations as well. But we just wanted to get a sense of how many people use other non-conventional data sources.
Seems to have slowed down here. We'll close in just 10 seconds or so.
Okay. Oh, there's a comment. Yeah. No. Okay, maybe if you can show us the results. Okay, so see a lot of people use location-based data, Bluetooth and Wi-Fi, trip planning apps, Twitter, CCTV. So it seems that many are actually experimenting with those new data sources and using them. Privacy there are privacy issues. So far, they seem to be manageable, but some also find them to be very challenging. So that's very interesting. And again, we will hear from our three distinguished speakers. So the format of this plenary session will be as follows. Each speaker is going to start with opening remarks, a short presentation if you wish, and then we'll open it up for Q&A from the audience and also from myself as the moderator. So without any further ado, our first speaker is Professor Jinhua Zhao, who is an associate professor and director of the MIT Mobility Initiatives Lab and in the Department of Urban Studies and Planning. Jinhua.
Sure. Thanks, Amer, for the introduction. Yeah. So today's topic I'll have is about the new data in urban mobility. I want to give two examples. One is about how to deal with natural language, right? There's a lot of new data sources in this semantic format, how do you take advantage of that? The second one is more of a challenge, and it's a generic challenge to deal with any locational-based data and how to treat off the privacy concern versus the utility of the data, right? Before I start, I want to acknowledge Dr. Peyman Nossalani and Professor Harris Kotsalas, who contribute together with me on the first topic, and also Dr. Alina Renda and Dr. Dajian Suo on the second topic, right? So yesterday in the one of the sessions we talked about this. There's a deluge of data coming in to mobility industry and transit specifically, including all the different things I list here. But I just want to say they're of different natures. Yeah, up to the mobile app, whatever complex the data is, they are in the traditional structured sense of the data. You can use the relational database to structure them, right? But there's another category of data is also coming along, which here I'm naming this semantic data, like incident logs, customer feedback, Twitters, Facebook, etc. So whatever those natural language-based data source here, right? So today we'll try to give a flavor of how do we handle the last category here. So part one on the natural language. So why text mining here, right? So any transit agency will accumulate a lot of this textual data, but typically they're like the incident logs, the customer feedbacks, and the social medias in general. But they're typically underutilized, right? Just nothing we done about it, just sit there. Or if we do it, it requires very costly manual work, decoding those data sources, right? The textual data is inherently unstructured, right? So give you a flavor. So what we get is, this is an example from a transit agency in a year. There are 20,000 records of these incident logs put in this spreadsheet. But the core column here is this narratives, right? It says that the 312 eastbound Central Line train 043 was delayed departing Leytonstone Station after male customer operated a number of passenger emergency alarm, etc. Right? So this is the typical example of this text-based data, right? So this is the source of the data. But what we want to really get is the following: is that we want to understand what happened, right? What are the causes of this incident? So what's the contributing factors, right? And after this happened, how it was managed. So what are the mitigating strategies we introduced, right? And then after this intervention, what were the consequences? What the delay duration, what's the impact on the trains, on the passengers? and what lessons we learn, what insight we can distill from this, right? So between the source of the data, this narrative, to this structured understanding, you can see there's a huge gap between the two, right? So if you look at the whole connection there, so from the real world, we have one type of data is through the sensors, right? AFC data, AVL data, RFID, all different things. You put them in numerical or categorical database, relational database, you use the general data mining, getting insight, get back. But there's another type, it's generated by people, right? And people writing down on their thoughts in this text data, yeah, how to do text mining and then generate actionable knowledge back to the real world. The particular method here is the following. We use this incidence report as an example, but it can be applied to many different contexts as well. The first thing is you need to pre-process the data to remove the stop word, the punctuation, correct the misspelling, etc. But after that, I put them into 3 buckets here, right? The first one is the incident classification, right? It's caused by what major things. So it's like a very typical classification problem. There are a lot of either the traditional method or the machine learning method you can use to classify that. In the middle, that's where we call this like a named entity recognition, right? For example, we know in this incident log, people report the train ID, right? So we know what we want to get. We targeted a search, right? It's kind of, we want to get the train ID out. And what's the station, right? What the other things, right? And then these first 2 buckets in the machine learning language, so the supervised learning, you have a defined label there, right? But then to the right, there's a last category, which is we want to discover interesting topic, interesting ideas without imposing a structure a priori. So that's an unsupervised learning context. You can use topical model, try to understand some of the interesting semantics we come out of this, right? So for most of them, I think I will skip, but there's one part I want to emphasize here is insight. What do you mean by insight, right? Here in this incident, we often see things like this. Whoever the staff coded this incident will say, also note that this incident could have been significantly reduced if the LU staff were allowed to access the track, right? It's a comment from the staff. It has an interesting insight, right? For this part, what we find is there's a regular expression pattern here. It follows the form of would have been prevented, minimized, avoided if something could have been done, right? They follow this regular expression, right? Again, once you have identify these patterns, you can use this pattern and search for those incidences appeared in the database. So here, if you look at back here, that's the different categories of things we can treat. We classify, we search for the named entity, and we use this regular expression to identify them. And also you can use this unsupervised learning to find the interesting topics, right? This is some particular machine learning architecture I won't go into, typical from this word embedding to the LSTM and the CRF layer, etc. Right? Let me show you some of the results. What can we find out of this, right? Based on the 27,000 incident log, this is one type of insight you can get. I categorize the incidences in 2 dimensions. The first dimension is by incident type, right? Is it caused by signaling system, failure by the fleet, by the staff not showing up or being sick, or by the customer or the public, right? This is the 4 main categories of incident type, right? On the x-axis is what are the responses? What are the control strategies that the staff take? You can cancel the train, you can reverse it, you can divert it, you can offer non-stop, you can withdraw it, right? So there's 2 dimensions, right? And based on 2 dimensions, you can categorize each incident into this map. This is based on this classification through the text mining techniques based on the incident log, right? That's kind of one type of output you can get that's useful for the operation there. The second type is you can then, given a particular type, for example, this is focus on cancel trip due to fleet problem. Once you have that, you can then put it into different amounts of the year and a different day, and then try to find a certain concentration. So for example, here you find often on June and July, there's a high concentration of this type of incidences. Similar, that's 2 examples. This example is different. This is based on the unsupervised learning based on topical model, saying that as a researcher, we do not impose any prior knowledge on this, just based on whatever sentences, the words there, to identify interesting labels, right? So here, for example, we put into two categories here. One is for whatever cause is attributed to the customer and the publics. Here are the top 20 topics that the unsupervised learning algorithm identify, right? They are like passenger emergency alarm, transpassing, passenger emergency alarm, door fading, etc. Similarly, for the staff-related incident types, there are not available, door open, wrong signal, etc. Right? So that's another kind of a way of discovering interesting patterns out of the data. Lastly, once you have that, you can kind of plot different distributions of the incidents by hour of the day, day of the week, different location, different causes, etc. Right? So those is only possible because now you can automate the process going through the 27,000 incident logs so that you can automate this process, right? The initial process is painful. You have to really go manually doing it and learn the pattern. And once you learn it, and then you can introduce this machine learning based methodology, then you can automate the process. Then once the tool is developed, that's actually very convenient to use and to digest also for different incident data. And similarly, on customer feedback, on this social media data, you can use a similar kind of framework to analyze this. So that's the first example, right? The second one is not about a particular data set. Instead, it's about how do we treat the locational privacy, right? Here I title it as a price of locational privacy with a specific meaning. We want to quantify the value for privacy, data privacy, in terms of if we were to protect the privacy, what efficiency loss we have to incur in order to protect the privacy, to offer a more precise quantitative notion here, right? Just one thing I do want to introduce first is I think the general public have a different degrees of sensitivity to different type of data, right? So for today, I guess if you ask someone, say, what's your income, people kind of get alarmed right away. They know income, that's a very sensitive thing. If you ask for the social security number, your health condition, people kind of have a very strong feeling about it, right? But the understanding of location and also people's sensitivity to it, I think is being developed. For some people may say, oh, who cares about location? What a big deal here. But actually, there's an important study to show that location is actually a very powerful identifier, right? This is a research, not by me, it's by this group of researchers there I'm quoting here. Just using this is a typical transactional data. You have the location, have user ID, which is anonymized, right? And a timestamp, and you may have a price range or not, right? So you find that with up to 4 such data points, you can identify up to 90% of the individuals, right? So this is really powerful. It's saying within 3 months credit card record of 1.1 million people, if you know 4 of such transaction points, you can uniquely identify up to 90% of those individuals. What it says is location as a data is actually very discriminatory in the sense of identifying the particular person out, right? So there's the recognition, at least from the research side, of the power and gradually developing sensitivity among the public to care about the location of privacy as well. The privacy concerns comes different setting, different ways. Database being hacked, then this another category is the whole facial recognition, etc. But within all these translation technologies coming out, right? There's a lot of this data coming with those both the technology or the business implementation here. There's then a generic question of how do you weigh between the data privacy concern and the data utility here, right? So that's a general question, and we want to translate it into a more specific one. So what's the trade-off between the accuracy and the granularity? Particularly, we say, what's the price of data privacy in terms of the decreased efficiency of the system and the quality of the service perceived by user, right? So this is a particular way of quantify the privacy's value here. For this particular case study, we actually use a shared mobility context. But here I just want to give you a general flavor of this. Some of the discussion I think are also very much relevant to the public transit settings, but the particular will be different, right? For in this case, we're looking at if people driving from home to work and they try to carpool in the work, but at the same time, an individual person does not want to share the exact location of my home address with the system. In this case, what can we do? So here I just say, pay attention to the middle part. There's different data masking techniques, including cloaking, obfuscation, and key anonymity. That's the kind of three very common ones. Let me give a flavor of what this is. Cloaking literally saying, instead of using the home address, you use the central sensor block central, right? That's very much the state of practice. Many of us are doing this. The second one is obfuscation. It's just to perturb the coordinate with some defined distance, right? So you can have a 100 meter, 200 meter, 500 meter radius perturbing the coordinate. The last one called key anonymity is to say that you generate k-1 fake positions within this radius, right? So now you have a k in total points, and the real one is one of the k, right? So that's called k anonymity in this process, right? So we apply these three methodology and applied it to the setting of a shared mobility one. So just want to demonstrate the impact of if you to mask the data, right? So here, compared to the situation where you have the precise location with the situation where you mask the data. So what's the consequence here, right? Particularly in this carpooling setting, one key thing is you have to pair people together. You can match two trips together, right? You can imagine if you have the masked data, you pull people together, some of the match may not be valid anymore, right? You thought the two are between A and B, and you can put them together, but A is actually not the genuine A, B is not the not genuine B. So the match we put together may be a bad match, right? So that's the trigger of the inefficiency. I won't get to the specific here, but let me show you the consequence, right? So here, this shows the percent of the match that can happen, right? So if in the real data, if the system have the real data, all the match should be good match by design of the algorithm, right? But this is to say that if you mask data, you can only match to say 70%, 60%, or 70 or 57%, or the match that's good, that's still valid, only 70, 60, or 50%. And the degree of which, if you just focus on these three columns, the degree of which is a function of to what extent you mask the data, right? In this one, see, for example, this one you mask by 100 meter, 200 meter, and 500 meter. So what is to show that is the more you perturb the data, right? Therefore protect the privacy, you have high level of privacy, but you have a lower percentage of the match that's good, right? Meaning you're reducing the overall system efficiency in the sense of the saved travel time, right? So here, this is more directly translating into the saved travel distances, right? Remember, the whole point of carpooling is to reduce the overall VMT, right? So this is try to say that, let's take delta equal 5, that's the detour time equal 5. Let's just look at this point, right? So if without masking, we would have saved n amount of VMT, right? These three line shows that the actual VMT can be saved if you preserve the privacy, right? Again, if you look between the three big groups, the three colors represent 100 meter, 200 meter, and 500 meter, right? So the more you mask the data, preserve the privacy, the lower you can save in terms of the VMT, right? So that's the general idea. And the minor differences between the dotted line, et cetera, those are the different algorithms here. We find the algorithm, the matter, but to a minor degree here, right? The difference between obfuscation, key anonymity, they're small. The big difference is the degree of privacy protection here, 100 meter, 200 meter, 500 meter, right? So as a summary, the privacy protection pay a price in two different perspectives. One is in the sense of system efficiency, the total VMT saved, right? More privacy implies a lower saved distance. there's some minor difference in the particular algorithm. The second one is the price of the quality of the service. As a customer, you experience a longer travel time if you were to protect the privacy more. So what this means for private companies here, because different users may have a different degrees of privacy concern, right? A possibility is to offer a tiered structure for different degree of privacy concern, right? So basically saying you can have either opt-in or opt-out structure, right? Or you can say, I'm opting in, but I need a masking of my location to such a degree. It's 100 meter, 200 meter, 500 meter, right? Given that privacy degree, then you can offer a different quality of the service, right? Similarly, from the public sector, the authority and the policymaker need to understand the balance between the privacy and the efficiency trade-off, and also the privacy and the quality service trade-off here. All right, so that's the second part. The third part will go very quickly, is more on the privacy's relation vis-a-vis cybersecurity. That's a distinct perspective here. Cybersecurity, I mean that in the mobility settings, for example, this is talking about the drivers that fake the GPS app in order to charge the higher fare, and it happens in many different contexts. To prevent this from happening, right? Because that's important, because the certain selfish behavior may generate these malicious scripts to abuse the system, right? It leads to resulting in a degradation of the overall service quality here, right? So the question then is how to protect the user privacy while detecting these malicious scripts with higher accuracy. Yeah, the way to do it is you can do it first with a manual way. You look at the trajectory and you can make a judgment saying this trajectory is not possible, right? It must be something, either the sender is wrong or malicious or some other trips, right? And then later you can also, once you learn this pattern, you can use deep learning methodology to help you identify those different patterns, right? But all of this is based on the fact, the assumption that the data are genuine, right? So you have the precise location. But here, if you were to say, I also want to introduce the privacy protection, right? We don't want the precise GPS location to be reported to whatever system that's utilizing this. That's where the trade-off comes in. The particular methodology is this differential privacy, this general concept introduced to the locational setting in the geo-indistinguishability by another paper. We applied this idea in the context of this GPS trajectory here, right? So here I just want to give you a flavor. Maybe look at this graph. So what this graph shows is the power of this overall capacity of the machine learning algorithm to differentiate between this normal trajectory versus the malicious trajectory, right? The idea is typically the higher this curve, the AUC, the bigger the AUC, the better distinguishable power the machine has. This is based on if without the privacy protection, right? That's the one thing, right? But then here, if you were to protect the privacy at the level of epsilon equals 0.01, that's a particular indicator of the degree of a privacy protection. This is actually the epsilon itself is the inverse of the privacy, right? So here, if you protect to some degree, you'll find the power of the model reduces moderate. If you have a very high privacy preservation criteria here, the epsilon equal 0.001, you may find the algorithm pretty much just collapse, right? So if you to protect the privacy to that degree, then the algorithm is no longer able to differentiate between the malicious versus the normal behavior, right? So all this saying that there's another level trade-off between protecting your privacy versus detecting this cyber attack and try to resist those attacks. All right, so lastly, I just offer a few kind of general remarks, right? Here, transportation industry in general and the transit in specific, we need a clear definition of this property right to mobility data, right? We need a set of precise rules that govern the ownership, the use, the transaction, and the erasure of this digital information, right? And this project, it's only one small component of this. We try to quantify the value of such location of privacy from the supply perspective, right? This is only understanding the impact on the system performance. We're not asking people to willing to pay for the privacy, for example. That's not a demand argument here. All right, so that's the one. The second one is more broadly, we really need a new social contract, right? As a society, we have a pretty well-developed institutions regard to land, labor, capital, but we need to do something similar for data, right? To define, track, and audit ownership of data. But here, let me try to emphasize the unique feature of data vis-a-vis land, labor, and capital. So why this is difficult? One is the data typically can be replicated at zero marginal cost. That's a unique feature one. Two, its value is inherently combinatorial, meaning you cannot define the value of data on its own, right? The same amount of data may be really valuable for a certain group of people combined with other data set. Well, it could be meaningless on its own, right? So that's another challenge, how to price it as well. And also the same, again, the value of the same data may vary widely depending on the different setting and application, right? So lastly, the authenticity is, and usefulness is harder to verify a priori, right? So that's got a few remarks. Today I want to say the natural language is an example of the many set of new data sets that we could use, while the privacy is more of a generic concern, generic challenge. I think whatever data source you're talking about, we'll encounter and we need to develop a system of. Right. Thank you.
Thank you so much, Jinhua. A lot of interesting ideas and very thought-provoking. Thanks a lot. I'm sure people will have a lot of questions. I have a few of mine. But we'll leave the questions to the end. So it's my pleasure now to introduce the second speaker, Scott Hale, who is a business analyst at Calgary Transit. Scott.
Thank you, Amer. Just share the screen here. So thank you for having me today. So distinguished host, panelists, honored guests. I'm Scott Hale. I'm a business analyst with Calgary Transit. Today, I'm going to be talking to you about using social media as a transit data source. Specifically, while I will touch on how we currently use it, I'm going to be talking about how we will be using it. Hang on, we got apparently a frozen screen. There we go. So to give you a little bit of sense of how important social media is as a data set, let's talk about the story of Calgary Transit and Twitter. Calgary Transit started using Twitter in 2009. And since that time, we have issued out from our account over 233,000 tweets. We have amassed 124,000 followers. And we are an important part of the community and context of Calgary. Currently, we have very basic usage of Twitter. We use the basic Twitter instruments to use it as a tool of communication and basic customer engagement. As we're moving forward, we identified that this was an area that we could better use as a data source. So we have established a partnership between the University of Toronto to create a social media analytics tool. And that's what I will be dealing with as we go forward. We did see some of that tool demonstrated on Tuesday. So I will be providing more of the business perspective about how we are going to integrate and use the tool and discuss the limitations and the processes around social media as a data set. So what are we talking about? Social media as a large data set is very capable of supporting decisions across a great many aspects of our organization. So why social media? I've already spoken about the volume and the potential for that data, but really we're talking about crowdsourcing the data. The data that we generate from our tweets goes out into the community and we receive responses based upon that. We also receive responses based upon the customer's experience of transit. And then there's a third type, which is the community generated feedback. So the comments, the topics, the discussions that our Twitter community will provide out on their own accord. These are all very valuable as a data set. With the tool that we are looking to do real-time or near real-time analysis of the data, as well as support a lot of decision-making using historical data. So as you probably saw, if you attended the Tuesday session where the Twitter social media was discussed by the honorable and learned academic delegate, really we're talking about a process with social media. And given that it is a language-based process, the first step is developing a lexicon, a dictionary, if you will, of terms that are very specific to the region, in this case, Calgary. We have very unique terms and a very unique language used by our Twitter sphere, if you will. So the process, and I'll just talk over this briefly as it was already talked about. The tool will pre-process data. It'll filter out so that only relevant data is provided into the system. The garbage data, the advertising, the spam or fake news, if to keep up with current terminology, is what we want to make sure that we don't capture. We want to exclude that. So artificial intelligence will classify, group, analyze the data, including content, the metadata, audience, networks, and more, to give us an intelligent way to look at it. We'll have capability of providing notifications on different types of events. And I'll go through that a little later on. And we'll produce business intelligence and use it in reports to extend the ability of Calgary Transit to be an effective organization for its customers. So let's talk a little bit about the actors involved. So the social media tool, the one being created by the University of Toronto in partnership with Calgary Transit, will provide the processing power, the artificial intelligence to really get to the data. From there, we will envision two streams. So the first is data that is triggered by an event or a parameter, and the second is the stored data. So talking a bit about the triggered events. When a trigger is activated, staff in the Operations Control Center are responsible for taking that trigger and then applying the appropriate process to get to the data that is provided in its structured form to the appropriate team, whether it's safety and enforcement, communications, the Emergency Operations Center, or transit operations. And I'll talk a little bit more about the triggering process. The other process, the historical data, is kind of your traditional view. So the data gets stored, it gets accessed for data visualizations and business intelligence, and it drives reporting. So now let's look a little bit more deeper at triggered data. So the input processing, the artificial intelligence filters out, gets to the heart of it. As part of that, there's a series of contextual triggers, whether it's based upon content keyword or matching a topic, a quantity threshold, such as a certain number of tweets in a given time, or metadata, so if we're looking for a particular location, say within the Twitter data. Let's go back to the content or keyword or topic match. So say, for example, the Twitter sphere starts lighting up with words such as accident, emergency, or terrorism. We would want that to trigger an emergency response process within the staff that is doing or is responsible for handling the output. So accident, emergency, terrorism would trigger the emergency response process, and the predetermined steps they would notify the appropriate staff and take the appropriate measures. Other words such as survey or campaign, or terms that we've loaded into the lexicon, would produce a notification that would indicate that maybe there's a communications or a marketing process that needs to be followed to, say, respond to the community or trigger that there might need to be an update sent out. Operational terms such as detour, no-show, off route, and so on can trigger a flag that can be sent to our operations team to address an immediate issue. Quantity thresholds are important just simply for analyzing the volume. If period over period we are seeing more social media posts, we want to know why. And so there would be an evaluative response to say, why is this being flagged? and to get the appropriate resources notified as to say, we are seeing an increase in social media traffic. What does this mean? What are the themes? What are they talking about? And the last one is metadata. And this is something where we want to examine, say, for example, locations. We put in a location such as a new LRT station, and we want to track all the tweets around that. We can track that social media traffic and then evaluate the response and send it off. Historical data, you're pretty basic. It's your traditional driving data visualizations, dashboards, operational reporting. We use it for business intelligence to look at community and network analysis, sentiment, topic analysis, geographic temporal analysis, and just generally improving our business. So what are we looking to do with an output as a business, as an organization? Well, the first thing is we're going to look at input into our Voice of the Customer program. We're going to look at the themes, the topics, what's important to the Twitter sphere, and we'll use that to drive customer-focused business decisions as part of the holistic approach. We will do community and network analysis. We will understand who our community is, who are the influencers, boosters, naysayers, and how they influence the community, and what that looks like in terms of Calgary Transit's ability to work with the community. And we will use that to better our response to the community and become a better, stronger member of the community. We will evaluate communications and marketing campaigns. We will use the Twitter response to surveys and campaigns to measure and to evaluate. We'll provide early notification and visibility on emergencies, emerging issues, and other topics of interest. We will combine with operational data to evaluate customer-facing performance of the transit organization, especially during abnormal or unscheduled events. We handle ourselves fairly well in events that we schedule and control. Sometimes, though, when we receive an unscheduled event, such as an emergency on the system, we struggle with working with the data we get and communicating out. If we combine this, the themes, the topics, the sentiment of the Twitter sphere, and we overlay it with the operational timelines of these events, we can measure our response and figure out how we are responding to the community, how we are handling the event in the eyes of the community, and make it better. We'll provide comparatives between repetitive events. Every year we host the Calgary Stampede and other events. As part of measuring the social media data, we can measure our presence, if you will, at these events and how we're handling it. And from year to year, we can improve and track how these events are handled from a transit perspective. And we'll give community feedback and narratives such as transit plans, fare changes, service changes, and more. How did the community feel about it? We will inform of potential training opportunities for staff. We will watch, especially around our customer-facing elements, what is the learnings that we have from Twitter that we can apply to it. We will improve our customer service and communications from this. We will look at the themes. We will look at how we respond to the themes and how the community responds back in kind. We'll drive improvements to how we use social media. We will try to use this as a learning opportunity to better ourselves in that presence. And we will use the business intelligence that we learn to help provide new information and levels of analyses to the reports, to how we present the work that we do to council, to committees, and to the community. So let's take a minute and I'll talk about the limitations of the process and social media as a data set. So as I alluded to at the start there, we do have a large data set in social media. The ability to process that data set does bring some juggling to the equation. The frequency at which we pull the data, the depth of the analysis of the community, how many layers within the Twitter community we go, and how deeply we analyze the data has very much a trade-off. If you want to have large community analysis, you might have to pull back and say we won't pull the data as often, or we won't do quite as deep analysis on the other things. So there is kind of a triangle trade-off. You can have more processing power, you can help that a bit, but money is not unlimited, so there is going to be that tension. The second thing is time spans. Twitter is not an instant platform. We note that people come online and they'll often participate in conversations afterwards, especially where it's not centered upon an event, but say it's a topic that we put out about future transit plans. The conversation might span weeks. So when we're analyzing the data, we need to keep that in mind. Next point, quality and viability of the posts. Some posts are of a high quality, others are not. Some will contain a lot of additional information, some will just be a few short words. We have to respect that broadness and learn how to interpret and act upon it appropriately. Slang, odd terminology, misspelled language will always try to foul up the analysis. Staying on top of the lexicon and understanding our community will be a maintenance aspect of this. It's going to take an investment in terms of manpower and just that keeping up with what is actually happening on Twitter. Other issues with using social media. So it is a limited audience. This does not represent all our users. So we cannot make any representative statements to say this is the entire community or this is all users. And when we look at particular topics and subgroups, sometimes we'll have small data sets, and we have to just keep in mind sometimes there will be ambiguous findings, limited outcomes where we don't have the social media posts to drive that volume that we need to really do the analysis. We're also subject to changes within the social media system. Vendors control the keys to the kingdom. We're not necessarily guaranteed if we try to expand to other social medias, platforms, that they will be around in the future. They won't be bought out. So we have to be very wary about the tools and what they access. Developers at these agencies can also change or remove features. Sometimes they may break out something that a process relies on. In that case, we have to be very mindful that they do control those keys to the kingdom, and we have to keep up with those features. There's also, they can add features that can improve how we utilize the social media as a data set. And sometimes that can have us evaluate the tool that we have in place to say, do we need to have updates to it to take advantage of these features? And some social media platforms are fairly frequent in these updates. There's also privacy and protection of privacy issues. While Twitter posts and the profiles may be public, as we start to correlate with other data sets and tie more intelligence to it, we're at the very real risk of running into privacy and privacy protection issues. And the last one I want to bring up is, being a community, it is subject to manipulation. Fake news, misinformation, especially around sensitive topics, can skew the conversation, skew the data. Now with transit, it is probably less likely as it is not a controversial topic, but we do have to be aware of that. Also, being a community, strong personalities and agendas can redirect or drive the conversation, and we need to manage that as well. So what I've talked about is kind of our present view of the tool that is forthcoming. As we go into the future, there are other opportunities. Automated analysis of photo and video media. What can that tell us? We look towards multiple social media platform support as more types of social media, such as TikTok or Facebook, allow more and more access. Can we use this information to feed or drive chat part artificial intelligence systems to help us with our social media presence and our responsiveness? And can we have higher levels of integration in terms of, our user data, and can we drive better outcomes from those? If we're going to have more intelligent data sets, what can we do for our users? On a last note, I would just like to discuss the collaboration with the University of Toronto. This project has been facilitated also through QTRIC and NSERC as funding partners. Something such as this nature tends to start in the academic world through initiatives like this, and we value greatly the partnerships that we have formed, as these types of initiatives don't exist typically within industry without the spark coming from these. I've been very happy to work with the University of Toronto and our partners, and I've been very pleased with where we've gotten to here as we move forward to implementation and evolving into the future. This is certainly exciting. So I'd like to thank you for your listening to me today. My contact information is on the screen. Of course, we welcome any questions you may have. Thank you.
Thanks so much, Scott. It's a very interesting presentation, which generated a lot of questions. You can actually, I think you've addressed quite a few of those questions already in the latter part of your presentation, but you may want to go over them and maybe answer them in the Q&A box. And if there are anything left, we can also discuss them later on. So thank you so much. So it's my pleasure to introduce Eric Mock, who's the Chief Enterprise Architect at the TTC, Toronto, Ontario. So, Eric. Eric, if you would like to share your screen, please.
Sorry. Once again, I have some technical difficulties here, so let me try to bring my my app back. One second.
Sure.
You guys able to see my screen?
Yes, Eric, you can go ahead.
Okay. Okay, so can you guys hear me?
Yes, Eric. Yeah.
Okay. So let me. Okay. You guys hear about how to use the data to improve the public transit, the AI, and Scott's talking about how they use the social medias in order to improve and help getting public opinion to improve their transit. So I am the Chief Enterprise Architect of Toronto Transit Commission. So Toronto TTC, if I don't know, most of the people's already heard and know about what TTC means. City of Toronto, we have 3 million, 4 million people sitting in the living in the GTA, in the Greater Toronto areas, and we have multi-million peoples and riderships on a daily basis that we serve subway, streetcar, buses, and wheelchairs. So in a daily basis, we have average of 4 million riderships in our services. We are running in multiple $1 million budgets to serve the Torontonians on an annual basis. So let us looking at the data source and how these neo data source would help us to improve and enhance our services in the future. So with the real-time information to location-based information, which is related to our smart bus, GPS location informations, as well as the Wi-Fi data, that help us in fact change a lot of our service perspective and planning perspective. So in the past, so basically what we are looking at the potential for the improved public transit is We now have the smart bus already implemented in most of our buses and the streetcar in the past 2 years. We are looking at communicating to the bus drivers as well as all the getting all the sensors information on a real-time basis. We're looking at the operational data, which is getting from the from our service planning, from our maintenance services. How we combine all these informations together and help to improve our customer experience is one of the biggest challenges that we are looking for, serving the multiple millions of the Torontonian in the future. So this information is what we are focusing on is how could we improve our scheduling and the efficiency, right? So which is people is always looking at whether the bus is on time, whether there's any subway train delay. The people's expectation always is if I'm sitting in the bus stop, the bus should be coming with the seat or with the capacity that I can get on. The bus load monitoring, I know everybody is now very concerned and aware of the COVID-19 situation. Lots of demand is like, how do I know that whether I'm safe to get back to the public transit, right? So that is one of the current challenges that from a management perspective that we need to see how we can improve that information and communication. We are looking at trying to understanding the passenger experience, their travel patterns, so that we can plan our fleet properly with better services and efficiency. Fleet management is how we can make sure that we have a really good maintenance plan so that we can reduce the breakdowns and we can have the bus availabilities to be up. Now, in an organization like us, we are talking about $100 million of assets, which is other vehicles, right? For the organization. If we are talking about 95% of availabilities that the asset will be able to serve the public in compared to 90%, that 5% is talking about hundred thousands or millions of differences, right, in terms of the asset. So it's a huge considerations in terms of financial sustainability about the organization. So what we has been done for the past years is actually we are looking at bringing in the GPS APCs that are the actual automated passenger counts data. So we, like what is just said before, in the past 2-3 years, TTC launched a big capital programs that we actually installed all the GPS locator, the real-time AVL systems in most of our streetcar and the buses so that we can have the real-time information about the bus location as well as the passenger counting. Operational data is related to all the subways that we have, all the sensors and IoT devices on the train. With our signal system, we are trying to get all this information into our enterprise warehouse so that we could do all those like a predictive maintenance, AI solutions. We can predict the train's arrival time. We can predict the delay and all these malfunctions that if there's any sensors that that they sense any abnormal activities on the train. So we are looking at also bringing in the scheduling data so that we could try to match the schedule data as well as the actual real-time run of our vehicles. So we could actually go in and change and reroute the bus or the streetcar such that we will, based on the traffic information, so that we can have a better services to our passengers. We recently launched the Presto card, which is a smart card of for the transit fare. So that we actually launched it starting from the beginning of last year, 2019. So in fact, those are also provide us with a really good foundation about understanding the travel pattern as well as the location information. We are also trying to leverage the IoT device, which we have all the Wi-Fi data, as well as the video image data that we could do a lot of neo analytics that we never done that before. The maintenance data, we are actually implementing a really sophisticated maintenance system so that we can help us to track all the standard repair time, the parts that they fail, at certain mileage or the service hours, so that we can predict the failure before it happens. So all this is going into our enterprise warehouse platform. Our platform actually will be able to provide information to our CEO office, which will be providing a really good decision insight, helping them to make decision in terms of how to improve our services, how to improve our operational efficiency. From a service planning, how we are able to enhance our service transportations and safety. So Jinhua and Scott also mentioned about a lot of analytics. So we are start looking at building the AI solution as well as the data analytics so that we could help to improve our safety. We are also processing the informations through the City of Toronto Open Data Platform, which we are actually exposed to information on a real-time basis, and people's now looking at the next bus app or any online apps that they can see the real-time bus schedule, the streetcar or the subway schedules, or the overcrowding information is actually published through the City of Toronto Open Data Platform. So this is basically what we are doing, and what basically is what we has been done and what we are doing to improve our the overall Toronto transit services. So when we look at the transportation data strategy, so we are focusing our primary data is the CAT AVL data, which is our real-time GPS location-based data, which is one of the really good primary resources for us to help improve our customer services. Automatic passenger counting would help us to understand what the number of people that use our services, the time and the patterns of how they use it. The advanced fare collections basically is the link to the Metrolink with the Presto cards that we provide to us with additional information that we haven't had before, with as well as the set of the operational data that from transit services, from transit control, which is the incident management system that provide us with all the incident information. Jinhua also talking about that the potential of using the incident log in order to diagnose and predict or prevent the information happening. So also we are looking at the potential of using big data, so which will try to link to the transit signal priority information system from the City of Toronto, understanding the ridership and the traffic conditions happening on the road with special events, natural disasters, and we are trying to link our bus services planning as into the weather event, as well as the seasonal periods, such as like a like a summer break versus the return to school. Now, one of the biggest challenges that we are seeing is the ridership drop because of the COVID-19, right? So actually, in the past few months, we see that we have a drop of from 80%, now it's back a little bit up, but we're still losing 60-70% of our ridership in this summer. However, when we know that the provincial government is now trying to help the recovery of the recovery of the COVID-19, and we are expecting the school will be resumed in September. We are actually working really hard to prepare when the school is back in September, what will be the potential ridership rise and how to ensure the safety and the social distancing. So those are relying on a really good data analytic and a source of the data strategy for us to help to predict the information such that we can prepare for the for safety return with the social traffic in September. Now, the organization basically, when people's looking at the transit organization, people always think about, okay, so transit organization is going to deliver the bus services to just run the subway. However, in fact, this is a really integrated, intelligent organizations that we are talking about. So with all this data's availability, the new informations that we are getting, we are actually putting all this together to help the management to look at how to enhance our planning and management so that we could actually make our services to be more efficient. How to effectively control and respond to any incidents if there's any traffic delay or traffic jam or any accidents happens or any incidents happen in our subway platform. How are we able to improve our response time so that we could minimize the impact to the customer? The proactive and predictive maintenance beforehand, we didn't have the information good enough to help us to do the predictive maintenance. Now we have all these IoT devices happening in our vehicle so that we can get the information to prevent the parts failures before it actually happen. By putting in all these informations together, which will actually help our management to make a more data-driven decision. One of the important aspects in the past few years that we start kind of transitioning from a transit agency into a service agency is we are more concerning and looking after the customer experience. It is not more about how we set the services to be delivered and how much efficiencies that we are at, but it's more about what our customers feel, what our customers say. So that is one thing that is really clean in the in our new data management mindset is it's not about we prove what we said. It is more about our customer to say to the customer perspective or perceive how our services is. So back to like Scott's presentations talking about Twitter, getting the customer's opinion. That is one of the important aspects that we are trying to move our organization into works to. So talking about this data, so we have the CAT AVL data that we can help and track our real-time performance that will help us to understand the runtime, the dwell time, the delay of the vehicles, which is all related to customer experience, right? Because when a passengers that they are waiting for the bus to come or they are sitting in the vehicles that the vehicle is not moving well. So those are translated into the frustration of our customers' expectation. So we could not control and eliminate all the traffic jam, but we should be able to do a little bit better to how to minimize the impact to our customers by having better understanding about our passenger load in different routes and the type of vehicle that we can better understand and plan our services to fit and meet the customer need. So operational data as well as what like what I just said before. So it's very important for us to make sure that our asset is being fully utilized. Like a 1% in improvement in our service availability is translated into millions of dollars in terms of the asset saving. So it's a really good benefit and advantage for the organization to look at to make sure that we have a really good operational efficiency on our maintenance and when we pay a schedule. So trying to look at the use case of using or leveraging the smart bus data. So the first use case that we had that I want to mention is when we now able to collect the real-time location and the loading information, so we can actually optimize the bus movement, because by understanding where the bus is actually located in compared to the original planned routes and the time. So our route supervisor will be able to direct the bus driver or the vehicle drivers to slow down or speed up or use alternate routes if there's any situations happen. So this is translated into more like a real-time communications for route management. Which we never had that before we have the real-time location and the load information. The AVL system also loaded with the IoT device that we can monitor the vehicle health such that we can actually feed the information into our garage supervisor if we can sense that the bus or the vehicles start to having some sort of potential failures. So before the actual breakdowns happens, we direct the services, we route the bus back to the garage for the fix before it break down. The real-time information for the alert and the passenger is once we have this information, so we can through our transit app right now to notify the passengers that there has been an incident happen either in a subway or delay in a subway or the bus route shutdowns or detour on a real-time basis. So this is basically the leverage of the bus data that open to us with a huge opportunities for improving our services and operations. So when we're talking about the service platform, service performance and communication, so I had mentioned about with this real-time information, so we enabled the real-time voice and the text communication so that our bus driver can always communicate with the bus supervisors, that they have full control and monitoring of the entire transit planning and scheduling, such that they will be able to alert the bus drivers to detour and going slower and faster in terms of like meeting the passenger needs. Preventive, predictive maintenance, I mentioned that. So now we already have all this information feed into our maintenance system. So we also put in the predictive maintenance analytic so that we could fix the components before it actually fail. That is actually a huge savings to our asset utilization. Crowd management is one of the very hot topics that we are talking about because of the COVID. So now people's always talking about whether I'm safe to, whether I will be safe to going back to the public transit. So in the coming months, which will be in September, so we are going to launch a new features in our bus time app, which is our real-time online bus apps that people see the bus schedules and the bus real-time information. So we are going to add into the apps that with a passenger load information, which is based on our real-time APC count status that we kind of integrated with our real-time CAT AVL system, so that we can feed these informations back to the public on a real-time basis. People, before the bus is coming, they can actually see the coming bus that the passenger loads on the coming bus. So the passenger can decide that whether they should get onto the bus or they should wait for the next buses. So this is a really important features that we are going to launch in September. We are also looking at leveraging the Wi-Fi data. So starting from 2017, so we are partnered with a companies that they are providing the Wi-Fi, free Wi-Fi connectivities in our subway stations. So leveraging those information by understanding that we can correlate the connectivity informations with the passenger counting, such that we will be able to help displaying find out on a real-time basis the platform crowding situation, as well as we can leverage the information to predict the actual travel time of our customers. So again, that is going back to what I had just said before. It's not about what we are talking about our services, but it's more about the actual customer experience or how they actually set. So when we say a train coming from Finch Station or a lot of stations to the south, which will take 30 minutes from our signal system, whether the actual customers has been experiencing the same thing, that is a really good reconciliations of leveraging the data from a customer perspective. So again, to help and ensure the social distancing happen in the subway, so we are actually working and partnering with the Wi-Fi data, Wi-Fi service provider to provide a social distancing subway map to help the COVID-19 recovery. So we are going to launch in September again that to notify and feed these informations to the public internet, as well as some mobile apps that people will be able to see the clouding informations on a real-time basis for all the stations, so that people can decide that whether they want to take the subway or they will feel safe to take the subway if there's no social distancing challenges happen in the subway station at the moment that when they try to take on the ride. So this is another services that we are going to put up in the next month. So this is more the future model of our transit travel experience. As what we said, so we consolidated the transit control data, the subway signal data, the Wi-Fi data, which will representing the customer experience, as well as all the incident informations into one dashboard that will help our transit control, as well as the public to understand what is the current, what is actually currently happens in our subway system and our entire transit system. So we basically leverage the signal data so that we understand the train is moving from station to station. We will be able to detect by the signal data that if the train is moving slower than what is scheduled, or it is extremely slow that we saw the red, so that the passenger will have a really clear understanding about the entire subway system, that which section of the subway system is now running slower than normal, and which one is actually having major difficulties, or the other sessions that they are running in a normal speed and a pace, right? So we can also display the scheduled travel time from station to station, as well as the predicted travel time. The scheduled travel time is based on our planning data, and we can actually compare it with our train signal data, so that we can tell that based on the plan and based on the schedule, whether the train is actually running according to the schedule. So they're just like you're running on the highway. So the provincial government is able to tell you that from point A to point B, what's the normal average travel time and what is the real current travel time. So we can actually display these informations such on a real-time basis, so that the passengers will be able to, in advance through their mobile app, to see that what is the predicted travel times that they are actually, if they want to get on from a station A to station B. Now we are also connecting with the Wi-Fi data, so that, like what I just said before, it's not about what we just said, it's about the actual customer experience. Because now loaded with the Wi-Fi connectivities, when a passenger getting into a station A, then we will be able to capture their connectivities, or their connection. When the persons travel from station A down to like a station B, let's say from Finch to Union, we can actually calculate the actual customer travel times based on the connections, such that we can actually compare the customer experience, the actual travel time, with what we believe to be the predicted travel time based on our train signal system. So this is a very important information that we never had that before. So now we can actually expose it to the customers, so that they can tell what is their actual experience, rather than what TTC is telling them that this is their travel time and any delay. In this map, in this dashboard, we can also show the station clouding information, so that they can tell whether the station is overcrowded from a social distancing perspective. We can set up different thresholds based on the different stage of the COVID-19 situations happening in the province or in the province or the city. So we can also show on a real-time basis of is there any ongoing instance happening. This information, the incident information, can show it on a dashboard that we can show it to the public, or you can post it to all the social medias or the Twitter accounts that people is like following the TTC. So these are all relying on our latest, greatest real-time data information to provide the new level of the services and the information to not only the management and the transit control in the TTC, but also for our customers to be more transparent and aware of our services as well. So historical data, we also trying to leverage the historical data. If people's now getting into use of the Google. So we know that Google launched a features months ago to tell the location clouding information. So we kind of leverage the same ideas that because now we have all this historical data of our passenger counting in any train, buses, routes, or station. So we basically can leverage all these historical data to build a histogram to indicate that at the date of the weeks that the passengers want to know at certain time from the hours that we start our service to the hours that we end our services, what is the average counting level according to the COVID-19, so we can set up different threshold for the counting levels to indicate that this is like a high crowding levels that may be having some social distancing challenges, or which is medium level or low level. We can also, by linking these historical information, histograms, into the live data that we, let's say if we can now knowing the bus or the streetcar or the subways, that what is the live data that actually happen at the current moment, so that we can compare the live clouding information with the historical information, such that we know that our current live data is about the same as the average for the past 3 months, or actually we are more clouded than the average of the 3 months, so that we can also understanding the trend as well. So this is a really important information to help us to manage the COVID-19 social distancing as a public transit.
Eric, I'll ask you to just wrap up if you can, over the next 2 minutes or so.
Oh, okay. So then we also trying to look at to leverage data for the advanced analytic and machine learning. Again, we can use the passenger data as well as our fare data to identifying the spot or the locations that we have the fare invasion most likely would happen. So this is again leveraging the AI or the machine learnings to help us to analyze the location. But again, this is the concepts that we are trying to put together. Video analytic is the next areas that we will start looking at, because with the digital cameras now happening almost everywhere in our stations as well as the tunnel. So we are looking at to see how we could help to manage the passenger crowding, or to reduce the crowding or hotspots in the organization, in the areas. So this is my last slide. So the privacy requirement for this new technology is really, really important for us as a public organization. We understand the privacy is very sensitive to the public. So with all the technologies that we had just said, using the video analytic, using the Wi-Fi information, I think one of the bigger challenges for us is how we can ensure and protect the privacy. Now, it's not only about the technology, it's also about how are we going to communicate to make the publics to accept and understand that their privacy is not being invaded by having these kind of services to put together. So those are the areas that we are actually working with a lot of different agencies, as well as our privacy commissioners, to look at how are we able to balance the technology and the use of the privacy and the use of the information, and in the meantime to protect the public's privacy. So that's it.
Okay, well, thank you so much to all three speakers. It's been definitely a joy to hear all about this. It's very insightful and thought-provoking. There have been a lot of activity on the Q&A, and some of the speakers already, I think Jinhua and Scott, have responded to quite a few questions. There are still a few left. We have maybe less than 10 minutes, but let's try to use this time as much as we can. I have a very quick question to Jinhua first. I think your first part of the presentation overlaps, I think, quite nicely with what Scott talked about natural language processing and their application, different application. In your case, you talked about incidence logs. Scott talked about social media. I just wanted to ask about your very, very interesting work on really quantifying really the effects of privacy protection. Have you thought of sort of costing this, putting a dollar value to it, to the different levels of privacy protection?
Yeah, I think in theory it's possible here, right? There are two levels of possible discussions. See, for example, if you are a mobility operator, right? If you say, because I need to protect certain people's privacy to the 500-meter degree, therefore my system performance measured by the total VMT need to increase because of this protection, and consequently the average waiting time and average writing time may also increase as a situation. So from supply side, you could, I think, put a price tag to that, right? That's one side. The other side is, I think, from the demand side, it's possible to envision the following. You say, I'm an individual passenger. I don't care about privacy. Give me the cheapest option, right? Versus you have to charge a premium in order for my privacy to be protected. Or you put another way around. Suppose the default is you protect the privacy, but if you don't privacy, you can offer a subsidy, right? That you can also potentially quantify the willingness to pay from the demand side, right? But the current situation is none of these are in any sense of the practice, because by default, if you look at Uber, Lyft, they take all the data in the most precise record by default. They just take it, right? They just take it and use it, right? So before what I propose to be anything meaningful, you need to clarify this property right. So who owns that privacy in that sense, right? If you clarify this, then potentially a meaningful marketplace can develop, right? For that, I guess we do need a public intervention here, because between an individual customer and the big operators, the power is so unbalanced. As an individual customer, there's no chance I can argue with the corporation, right? You need a public intervention at the collective term, right, to specify the mechanism here.
Mm-hmm. Okay, thank you so much. I know Scott has been quite efficient in answering all questions addressed to him. There are a few questions to Eric. Eric, I don't know if you had a chance to, you want to respond to any particular one of the questions in the queue?
Yeah, so I can answer a couple of them online, and I actually responded one on through the text as well. So I can try to address Cindy's question. So she is asking about, can you elaborate on the data collections and analytics of passenger experience for TTC? Yes. So this is a really interesting areas that we just exposed ourselves to. So when we say passenger experience, so what we had the meeting with our management, executive management, as well as city council, and some of the public opinion representative, is really interesting that we want to, we're being told that TTC will need to be more transparent and understand what the passenger feeling instead of what TTC tell the passengers that how good our services is. So when we try to collect the information, so now we are talking about the Wi-Fi data, which we will be able to help us to understand the actual travel pattern, the experiencing of using the Pastel card, the Metrolink information, so that we can tell that when people's getting in through the turnstile, is there any delay or any situations that they had encounters with not a smooth business experience. The APC data will also help us to understand how crowded the bus or the vehicles now they are. So by consolidating all these data into our warehouse platform, we are actually able to do our analytics to understand what the passenger experience from. Number one is what's their satisfactions about the service time, right? So the actual travel time in compared to what we believe to be the services that we are deliver. The crowding management, like what we said, is one of the important areas that we want to look at and help the passengers to reduce if we see that the bus or the streetcar or vehicles at certain time at certain routes that we are overcrowded at most of the time. So those will help us to do a better planning. So we are trying to leverage all these informations to understand the passenger experience from that aspect. So I hope I answered this question. Next question is, will the TTC bus crowding information only be available on TTC app? Oh, okay. So we started collecting this bus crowding information. So we will be posting these informations in a TTC website, as well as we are going to make it public. Now, there might not be necessary be able to make it public through the public API or open data in September, but we are in the process of making it happen. Like what I said, the bus time is one of the transit apps that TTC offer. We'll have those information. The next bus that we are actually working with them is another very popular mobile app that is happening in Toronto. They are going to launch a new version sometimes in November this year, and we are in the process of providing them with the information set as what they need.
Good, thank you. Scott, I have a question to you. I know you answered this already, but I just wanted you to elaborate a little bit further on it about really the cost implications of such platforms that process social media content. And you mentioned that really cost saving is not particularly an objective, but there are still some cost saving implications. So I just wanted to hear you a little bit more on this point.
Thank you, Amer. The project that we are undertaking isn't so much about cost savings as it's already been indicated, but along the way we expect to find, if you will, efficiencies in how we conduct some of our services. There might be faux pas that we might be able to detect, that we might be able to avoid doing something that might cost us. So we might have cost savings from not taking missteps. This is an iterative process where we're building upon the community. So we learn, we apply the learnings, we improve, we do better for the community grows, we get better data, we learn. Along the way, we are hoping that we'll find opportunities to apply those learnings to produce a cost savings along the way. What they are, what they look like, we're not going to try to predetermine, but we'll keep an open mind as we go to where we can find them as we go, as they become something that we become aware of.
Thank you. I would have loved to keep going, but unfortunately we're 2 minutes over the time of the session. I would like to thank really our distinguished panel. It's been really very, very enjoyable set of presentations with a lot of new ideas and a lot of potential really for improving our processes in transit agencies to improve both efficiency and customer experience. Well, thank you again so much. And again, I remind you for the lunch activity, we're going to have a tour into the history of public transit in Toronto. So please join us in about less than 1 hour. Thank you so much.
Thank you. Thanks, everyone. Scott,
Thank you.
nice to meet you guys.
Yeah, nice meeting you.